So with word problems, what I would say is the more you can read it, obviously the better. Nobody usually likes to do that. But the more you can read it, and then the more notes you can make for yourself, the better. Color coding, using appropriate letters, things of that nature. Because as you well know, most of us, when we look at a word problem this big, like all of a sudden just go, oh, and mark C and walk off. So we don't want to do that. It's not that hard. So Rob and Stephen each improved their yards by planting grass side and ornamental grass. They bought their supplies from the same store. Rob spent $92 on 11 feet of grass side and 4 bunches of ornamental grass. So the two things we have are going to be side and ornamental grass. So that's what we're comparing. So side, ornamental grass. We'll call that an S, and we're going to call this a G. And I like to use the letter of the word rather than the X and Y. Usually it's not super helpful for Desmos, but for word problems, that way when I'm finished, I know what I have instead of accidentally grabbing the wrong number. Because should it be a multiple choice question, both numbers of sod and ornamental grass will be there, depending, and they don't always ask for both. So you want to make sure you're staying focused on answering the question that they ask. So Rob spent $92. So Rob spent $92. And Steven spent $140. So we have stuff and then we have money. Stuff and money, it sounds like. So Steven spent $140 on 11 feet of grass side, so the same for the grass side, and 8 bunches of ornamental grass. Find the cost of 1 foot of grass side and the cost of an ornamental grass. So we're doing both. So Rob is $92 for 11 feet of sod plus 4 bunches of grass. So that's going to be Rob's. Stephen or Stephen is going to be $140 for 11 feet of sod and 8 bunches of grass. Now, when you're trying to decide whether to do elimination, substitution, or graph it in your calculator, at this point, if it's calculator active, if you can get this far correctly, you can do your calculator active and just type it in the calculator. I am going to do it with you elimination style first to make sure that we practice it, but on EOC or quiz or test day, at the end of the day, we want to get it right. So for elimination, it's the addition rule. So we're working up and down. We're going to add straight down. And when we add straight down, we want something to cross out. It's easy to turn a 4 into an 8. We could multiply it by a -2, but we have matching 11s. So if we multiply one of these rows, and in this case, we just need one of the 11s negative, so it doesn't matter which one. I'm going to do the top one, multiply by a -1. That gives me a -92, -11s, and -4g. Now you're going to focus on, you can rewrite it over to the side if you want. I'm pretty lazy. So I'm just going to look at these two. The guy at the top we've redone. And we're going to add straight down. So 140 plus that -92, or 140 minus 92, is going to give me 48. Sorry, I was looking for my calculator while I'm looking around. So that'll give us a positive 48. So we're actually going to, and then these guys are going to cross out, because if I have 11 and I lose 11, they're gone. And then if I have 8 and I lose 4, I have 4. Now we want to solve for g. That's 4 times g. So what's the inverse operation of times g? How would I get g by itself? Yeah, we're going to divide by 4. Perfect. 4, and 48 divided by 4 is going to be 12. So g equals 12. What is the cost of 1 bunch of ornamental grass? $12. So that one we've answered. Now that we have g, we have to go back and solve for the side. You can plug it in either equation, the top one or the bottom one. I like the top one in this case just because the numbers are a little smaller. So 92 equals 11s plus 4. And we're going to take that 12 that we found as g, plug it in here, and then we're just going to solve. So we have 92 equals 11s plus 48, and then 48 subtracted from 92. It's going to give me 44. I'm running out of space. Eek. So 44 equals 11s. So how much does the side cost? How would you solve for s? So we'll divide both sides by 11. Yep. And so side's going to cost $4. So in this case, the question did ask for both. So then this is our answer, and this is our answer. So we're good there. Okay, so moving right along. The indoor climbing gym is a popular field trip destination. This year, the senior class at high school, sorry, I feel like I'm too close. Like now maybe it's hard to read. Let's go back one. There we go. The indoor climbing gym is a popular field trip destination. This year, the senior class at high school A and the senior class at high school B, so we're comparing two high schools, both planned a trip there. The senior class at high school A rented 4 vans and 3 buses with 212 students. High school B rented and filled 10 vans and 3 buses with 260 students. So what I like to always think about are what are my totals in that? Like, what's the big totals in that problem of the two conversations from school A and school B? What do you think are the two totals? Which of those numbers are totals, like are equal to? So school A has how many students going? So school A has how many total students going? 212, perfect. And then school B has how many students going? 260, right? Perfect. And then they took vans and buses. So I'm going to do vans plus buses. Vans plus buses. So school A, how many people are in a van? 4. How many people are in a bus in school A? Yes. Then we're going to do the same thing for school B. School B has how many people in the van? Or how many vans are they taking? 10 vans. And then how many buses are they taking? So I didn't answer those questions right the last time. I'm sorry. They took 4 vans and 3 buses for school A. School B took 10 vans and 3 buses. And their total number of students in each was 212 and 260. So with that said, again, work in elimination, and I didn't show you Desmos on the last one. I'll show you Desmos on this one. After we're done with our elimination, 4 is pretty hard to turn into a 10 by multiplication. You can multiply top row and bottom row to make them match, but that's a lot of math, and the less amount of math you can do, the less mistakes you have room to accidentally make. So I have matching 3s. I just need one of them to be negative. So again, I'm going to take the top one, because then I can just rewrite it underneath and scan down. So it's going to be negative 212, negative 3b, negative 4b. And again, so now we're going to focus on these two equations. So school A is now at the bottom and school B is on top. We're going to add straight down. So if I have 10 vans and then I add in negative 4 vans, I have how many vans? So working straight down from 10b minus 4b is going to be 6 vans. And then the positive 3 lose 3. It's a 0. 260 minus 212. It's going to give me 48, or plus the negative 212. And then you want to solve for vans. So we're going to divide by 6 on both sides. And how many vans did we have? Yes. So they took 8 vans, or I'm sorry, 8 students fit on each van. So the question was, each van and they carried the same number of students. Find the number of students in each van and each bus. So 8 students excuse my dog, sorry guys, in each van. And now if I have 8 students in a van, I can figure out how many students I have in a bus. You can pick whichever equation. I'm going with the smaller one. So 4 times 8 plus 3b equals 212. So 4 times 8 is going to give us 32. Plus 3b equals 212. You want to solve for 3b. I'm going to pause for a minute and see if you guys can solve for 3b and just come back and give you the answer. So how many students fit on each bus? Good job. So 60 students per bus, 8 students per van. Ta-da, we're done. Now, if you can make sure that you make a note to yourself, so we'll call vans X and buses Y. If you decide to do it this way, I highly recommend making a little table over here in the corner, just like that. Seems really silly and like a lot of extra steps, but just trust me, it'll keep you from making a really silly mistake. Let's see if I can go find my Desmos. I opened it. Where'd it go? Whoops, sorry. Huh. Guess I didn't open it. Give me 1 second to get some Desmos going. So I can show you how you can do this guy. But again, it's making sure you keep your X's and your Y's separate. And by separate, I mean like you remember which one goes where with what discussion you're having, like whether it be vans or buses in this case. It is struggling. Maybe this is why I didn't get it last time. There we go. All right. So we had 4 vans. I'm going to use vans for X. That's going to be 4X plus 3 buses. Whoops, I'm calling that Y. Equals 212. That's your first one. And then we're going to write in our second one, which was 10X, because X is vans, plus 3 buses, which is going to be our Y, equals 260. So we have both. Whoops, that's not equal. That's a plus. Equals 260. Now, we don't see it because think about these numbers. These are fairly large numbers. And if you were to isolate Y in this case, you definitely have to divide 260 by 3. So it's going to be about up in the almost 100. So pretty close. So we're going to go way out and we're going to go way up for sure. There's a blue line. Yay. So we're getting to the blue one. There's the red one. Excellent. And then our intersection is 8 and 60. So again, if you remember that you set up vans as your X, then there's your 8. And if you remember you set up buses as your Y, there's your Y. So 60 per bus, 8 per van. I think a little easier if you have access to a calculator, so it's not the calculator inactive section. Don't only rely on this way, because when you get to Math 3 and you do SAT and ACT, they don't give you the same Desmos to use. Math 3, the EOC, you do have Desmos, but your ACT and SAT, you don't have Desmos yet at this point to use. You would use a regular calculator, which you can do this in a TI-83, but your formatting for your equation has to be in slope-intercept form, so you would have to solve for Y, which is a lot extra. By the time you do all of that, you are likely spending more time than just doing the elimination form. So we'll look at the next one. So May goes to school and is selling tickets for a fall musical. On the first day of ticket sales, the school sold 4 senior citizen tickets and 1 student ticket for a total of $23. Now, all these questions are fairly similar, and I did that on purpose so we can drill and kill this type. They will change it up a little bit, but not a whole lot. So they're selling tickets. They're selling two types. So senior citizen tickets, and then we have May, and then we also have student tickets. The school took in $46 on the second day by selling, so it's first day versus second day, senior tickets and senior citizen and student tickets. What is the price of one senior citizen ticket and one student ticket? Again, all of these questions are asking you for both of your quote-unquote X and Y. Most of your EOC style questions will not ask for both. They will ask for one or the other. And typically, I would say they're probably going to ask for the one that's a little harder to solve for. So I'm going to call senior citizen tickets my X value, and I'm going to call student tickets my Y value. What are my two totals? So like, what's the total for day one and the total for day two? Yep, 23 and 46. Perfect. So we know we got 23. We know we got 46. We know we have senior citizen and we have student tickets. We have senior citizen and we have student tickets. The part you have to fill in is for day one and day two. How many senior citizen for day one? We had 4. And how many student tickets for day one? We had 1. And then for day two, 2 senior citizen and 12 student tickets. Now, 4 does not match 2, 1 does not match 12. Though I will say, in my humble opinion, they are both fairly easy to switch. Like, I could turn the 1 into a 12 by multiplying by a negative 12 to get the opposite but matching number. I don't think I like the idea of multiplying 23 times 12 and then doing all that subtraction. That number just gets big. I do think that multiplying the bottom equation, so that 2 by a negative 2, is a little easier because then I'll have my matching 4s and I can do most of all that math in my head. So this could be, definitely if this is calculator inactive, I would not multiply everything at the top by a negative 12 because 23 times 12, not that it's impossible, it's just not easy multiplication that you should be able to just ramble off. So our second equation, we're going to distribute that negative 2. And that's equal to 92. Yep, 92. Negative. Make sure you hold on to your negatives. I caught myself making that mistake a ton yesterday. So I'm going to rewrite the top equation down here just so that way they're together. 4x plus 1y equals 23. Now you're focused on the two equations in the bottom, and if you want to write them over to the side and rewrite that one, that's fine, if that's easier. They do match, so we're going to add straight down because our front terms match. So boop, boop, 0. If I owe you 24 and I pay you 1, I'm going to owe you 23. If I owe you 92 and I pay you 23, then I'm going to owe you 69. We want to get y by itself, so we're going to divide by negative 23. And y is going to equal 3. Negative, negative gives us positive. Now, y is 3, so that's student tickets is $3 a piece. And I would go ahead and make that notation on your quote-unquote table, like I said, where you name it X, name it Y. I need senior citizen tickets, so we're going to plug in that Y. I'm going to go with the first one again, because this time I'm going to use the first one, because it's a little bit smaller numbers. So 4x plus 1 times our y equals 23. And our y value we found was 3. 1 times 3 is 3. So 4x plus 3 equals 23. We want to get 4x by itself. So we're going to subtract 3 from both sides. So 4x equals 20. We're going to divide by 4. And x is going to equal 5. So that means senior citizen tickets are going to be 5. Again, if you go to Desmos, so you have to be able to set up the equation. You can go to Desmos and type this one in the first one, This one and the second one, not even worry about your multiplication or switching it to slope-intercept form, and find the intersection. So ultimately, worst case or best case scenario, depending on which side of the fence you stand on, you have to be able to set up the initial equations. And then for all, like that is a non-negotiable, we have to figure that out. And then either be able to put it into Desmos and find the intersection and keep your x's and y's straight, or solve by elimination. And then I'm going to skip some word problems. And we're going to get into inequalities because that's the next part. Does anybody have any really major questions on word problems? Are they getting easier the more you see? Hopefully. All right, cool, perfect. Okay, so graphing these inequalities. Y is less than or equal to. So y is less than or equal to, you are going to focus on your y-axis for the less than or equal to. So looking on the y-axis, which side is less than typically? So we'll just use the x-axis as our benchmark at the moment. Would I have greater values above it or below it? In this case, we're doing less than, I'm sorry. So less than, would that be below the x-axis or above the x-axis? Below. This is where you're going to get smaller numbers going this way, right? So that's going to be your less than direction. Now, what's the slope if we rewrote this just linearly? So y equals negative x minus 2. What's the slope of this line? So like rise over run. What would be the fractional slope of that line? So what's our m value of that line? Negative 1 over 1. And then looking at that equation, because that's a negative 1 in front of the x, what's the y-intercept? No, looking at this equation, the y-intercept, what's your b value? And y equals negative x minus 2. What's the constant? What's the number with no variable? Yep, perfect. Negative 2. So we're going to go to negative 2. That's going to be your start. And then it's going to be a negative 1 to 1. Down 1 over 1, down 1 over 1. And because it's an equal to, that makes this a solid line, which would be like a closed circle. So we can go ahead and do solid. If there was no equal to, it would be a dashed line. And it does matter. 100% matters. And if it happens to be a multiple choice question, that's how they get you. Now, my conversation earlier was to put the arrow on the right side. So because it's y is less than or equal to, you're going to shade the entire region, sorry, I tried to put those words together, underneath. Ta-da, you're done. You've just graphed a linear inequality. So look at number 8. That's y is greater than or equal to. So is that going to be above the x-axis or below the x-axis? Greater than. Above, right. So we're going this way. And then we're going to graph our line. So looking at our equation, so we're going to rewrite that equation in our mind as y equals 3/2 x plus 5. All right, boys, talk to me. What's my y-intercept of this equation? What's my b value in that equation? Yep. Thank you for not leaving me hanging there, Maddie. Yep. Thank you, Ela. Okay, and then what is my slope? Good job, good job. All right, so get rid of the x in your slope. The slope is just 3/2 because x is input, y is output. They have different jobs. Your slope is just the 3/2. So we're going to go to a positive 5. It's a positive 3 over 2. I can't go up and over, so I'm going to go negative 3, negative 2, because that's a double negative, which makes it positive. So negative 3, negative 2, negative 3, negative 2. Again, this is an equal to, so these lines are not dashed. It's solid. And it just continues in both directions infinitely. Now it said greater than, so my green arrow is above the line or below the line in this case. The line we graphed. Like before we were drawing the arrow relative to the x-axis. Now we're looking at it in comparison. So it's going to be this way. We're going to shade in that portion of your graph. Now what that is saying is that any point within this shaded region, so if x was negative 2 and y was 6, if x was negative 4 and y was 2, would make this equation, this inequality true, because this is a greater than or equal to. So if I plugged in anything. Now, because it is a solid line, all of these coordinates that are falling on the line are also true. Had it been a dashed line, they would not be true. And in this case, I didn't color all the way to the line, which is probably a little misleading. It goes all the way up to the line. So every point that falls up there, like in quadrant 2, above that line will make this statement true. Now, number 9, what's the y-intercept for number 9? Negative 4, perfect. So our b value is going to be negative 4. Our slope is going to be what? 9 over 5, good. Lovely. So when we go to graph it, now y is greater than or equal to, is greater than or equal to above the x-axis or below the x-axis? Above. So we're going to go ahead and draw us a little arrow up here on the outside of our graph. And the reason I don't do it from the x-axis is because once I put my line on there, it might be more confusing. So I just put the arrow on the outside. So now I've got all my bases. So b is negative 4, so I'm going to go to negative 4. I have a positive 9 over 5. Going down 9 and left 5. So negative, negative is coming off the graph. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. Beautiful. Again, it's an equal to. So this is going to be a solid line. And it may be easier. You guys won't do a lot of hand graphing, but use the corner of a piece of paper. Use anything you have to, if you ever have to do that, just because it makes it nicer and neater and you don't confuse yourself with crooked lines. Now, it is greater than, so our green is up here. So we're going to shade towards our green. And some of the questions they will ask you will be, is so-and-so a solution to this equation? So let's see. Is the origin, 0, 0, a solution? And when I say, is it a solution, what I'm asking is, does it fall in the shaded area? So does 0, 0, that coordinate, fall in the shaded area? Yep. So that means that is a solution. So that's a yes. Is 3, 4 a solution to this inequality? So does the coordinate 3, 4 fall within the shaded area? So 3's first. 3, 1, 2, 3, 4. So that one's a yes, right? Is 5, I'm going to give you an easy one, 5, negative 1 a solution to this inequality? So remember, your first number, you're going right, left. Second number, you're going up, down. So we're going to go 5, negative 1. Yep. Not in the shaded area, so no good. So each one of these are a solution to the above. This one is not a solution. And then sometimes they say, hey, name a solution. So pick any point you want over here in the shaded area, and that's a solution. Now, number 10 is not hugely different, but just one call out before I show you Desmos, and we call it a day. For looking at number 10, y is less than. Is that above the x-axis or below? Below, yep. So we're going to draw an arrow down here. So we're shooting for in a little bit. What is my slope for number 10? What's my m value? Rate of change. Yep, negative 1 over 2. Perfect. What is my starting point, otherwise known as y-intercept? Yep, negative 4. So remember, your slope is always, the other word for slope is coefficient of x. And coefficient means it's attached to a variable. So coefficient of x, your slope is always attached to the x. Always, always, always. And then, especially in slope-intercept form, so y equals mx plus b. And that's the form this is, when y is isolated. So we're going to go to -4. We're going to start there. It's a -1 over 2. So I'm going to go down 1 to the right 2. That's a -1, positive 2. -1, positive 2. If I go the other way, I'm going to go +1, -2. +1, -2. +1, -2. Now, this is a less than. There is not an equal to symbol. So that means this becomes a dashed line, which think about it as like a chain link fence. That means you can't sit on it. So anything that falls on that line is not a solution. But everything less than, which is, we drew our arrow down, which is going to be down here, is a solution. All right, so speaking to solution or not a solution. Here's our test question. Let's go. Let's do origin again. Is the origin a solution to this inequality? So is 0, 0 a solution to this inequality? No, right, because it's in the non-shaded area. How about is -5, -4 a solution to this inequality? So it's going -5, 1, 2, 3, 4. That is in the shaded area, so indeed it is. That's a yes. That's a no. All right, I'm ready. Brace yourself. Here's the trick. So 0, -4. Is that a solution to this inequality? So 0, -4. Good, it's not, because it is a dashed line. Had it been an equal to inequality like the examples prior, then it would have been a solution, but it's not an equal to, it's just a less than. There has to be an equal to for the line to be a solid line. Now, just a quick hit real quick in our last 2 minutes. Oh, if I can get my mouse to work. There we go. If we go here, you can type in your inequality. There it is. Calculator. So we're going to type in, we'll do the last one. So that was y is less than, and you can use the keyboard for less than 1/2. It did not give me my 1/2. Well, that's making a mess. 1/2 x. And then -4. -4. And we are off in La La Land, so I'm going to go click the home to get back to where we were. And there it is. Dashed line, shaded below. Any point that falls wherever. So if you wanted to try, like we said, 0, 0 was the first one we tried. 0, 0. You're looking, that purple dot is not in the green area, so that's a no-go. On the, we did -5, -4. So we would have to get rid of our keyboard or slide around here. This is in our shaded outer area, so we know that one. And again, the only part that you have to remember that it won't tell you, I believe. I just had another idea, though. It might. 0, -4 does fall on that dash line, so that is not going to work. But it shows you the dot, so you don't have to always. I know some students have a hard time remembering left, right, then up, down. So when they get confused, especially after doing 60 questions, like on an EOC or something, or quiz day, get really upset, and it won't give you a table. Trying to think of ways. I guess not. Yep, you just have to know the dash line is a no. Like it's not gonna, if it falls on this dash line. So this guy is not a coordinate here. If we put one here, -4. I'm not on it yet. Whoops. But dash line, no good. Solid line, perfect. Colored area, great. Not colored area, no good. No good. And that's for single inequalities. So graphing is important to understand how it happened. But again, you have Desmos probably more apps than not. No, there are no notes on the EOC. Absolutely not. Your biggest gift is the calculator active portion of that test. The rest of it you have to have memorized. Yep.